This is Larry again, and this is a YouTube video, part 2 of my backyard riding train series. This video provides an update of what has been done since part 1 and provides design guidance how to build a Calliope car. Make sure you view part 1. Part 1 of this series shows how I built a backyard riding train for my grandchildren. Boy, do they love it. Part 1 video provided construction details on the engines and track and showed how you could build the layout at a very reasonable cost. Part 2 video will show you my latest expanded layout with 2 more engines and additional cars. Also, it will show you how to build a Calliope car to provide music and sounds for your layout. Here it is playing. You guessed it, I've been working on the railroad. The Calliope car is constructed using PVC for organ pipes and air valves, a 12-volt air mattress inflator for the air source, DC solenoids, a 12-volt battery, an Arduino microcontroller, and various other electrical components. In addition to some metalwork and woodworking skills, you will need some programming and music skills. However, these are basic skills, and if you have a computer and access to the web, the skills can be acquired quite easily. Learning how to use the Arduino microcontroller opens the door to many other interesting and fun projects. I added 2 spurs to my main line to take the trains to additional areas on my property. One spur went to the east and the other to the west. To the west, I had to descend about 3 feet to get to level ground, and this required me to build a small, basic bridge. A switch from the main line takes the train to the west spur, and another takes the train to the east spur. Another switch takes the train back onto the main line. Using these 2 spurs allows me to change the direction of the train on the main line. Also, the spurs allow the trains to be stored off the main line and in a train shed. In some cases, the trains must be backed up to change its direction or exit the main line. The railroad shed allows for me to store out of the sun and rain 2 engines and 2 cars. The solar panel on the roof of the shed is for charging the trains. Additional engines and cars are removed from the track during rainy weather. It is planned to add an additional switch and spur to allow the additional engines and cars to be moved under a patio cover. I built 2 new engines and 2 new cars. I used the same basic construction approach as shown in the first video using 12-volt DC motors with train drives to the wheels. The first engine is an attempt to model the Disneyland train number 3 Fred Gurley. Measurements may not be entirely correct, but aesthetically the engine looks good. The second engine is a yard switcher. The cab is made out of aluminum sheet. The other 2 engines I have are the Super Chief and Thomas the Tank Train. I added 2 new cars, one for a passenger that is pulled by Thomas and the other the Calliope cars. All cars use a standard connection so they can be towed by an engine or linked together. Now we will go into the design details of the Calliope car. The base for the Calliope is any type of car you desire that will fit all the equipment. For me, I just built a gondola on a platform made from one Super Chief truck without a motor. See part 1 video for the dimensions, design approach, and parts for that truck. The pipes are made from 3/4-inch PVC pipe. A triangular cut, 1/2 the diameter of the pipe, is made in the bottom of the pipe starting about 1 inch from the bottom. A 3/4-inch diameter, 1 inch long wood plug is pushed into the bottom flush with the bottom. The plug has been flattened on the round about 1/8 inch the entire length so air can pass by the plug to get to the cut. A PVC cap is placed on the top end of the pipe. Airflow, temperature, and air density with the length of the pipe determine the note. Too much airflow will cause a note that is less pure. The length is very critical. Experiment building several pipes so you can get the feel for building good sounding pipes. For more detail on pipe construction, Google PVC whistles. Each pipe has an air valve. They are constructed from PVC pipe fittings. The objective is to get a valve that can be opened with a solenoid and when closed prevent air from flowing. A 3/4 inch T is used for the base with a wood plug on one side for the valve seat and a sleeve on the other side to support the valve plunger and restrict air. The plug has a 1/4 inch hole through the center and with one side sanded flat. This is the seat. It is forced into the T till the seat surface is centered in the upper outlet of the T. The flat portion of the seat faces the side where the plunger will fit. The face of the plunger should be flat and covered with some material that would seal between the seat and the plunger. I use 3/4 inch circular cabin door bumpers. Make sure you get a good seat seal and that the plunger moves easily in the sleeve. The connection to the solenoid is as you design. The source of air for the pipes is a 12-volt air mattress inflator. It is mounted in the car with the air intake on the bottom and the output through PVC pipe at the top. The inflator is put in a sound-insulated box to reduce noise. The volume and velocity of the air is critical for both proper flow for the pipes and for reduction of noise. Too much velocity causes excessive inflator noise and turbulence in the pipe, causing poor note quality. A rheostat is placed in series with the inflator to allow for adjustment of the volume and velocity. I used 8 pipes tuned for an 8-note scale. Unfortunately, the music for I've Been Working on the Railroad needs 9 notes, 2 of which are sharps and 1 a high C. I adjusted the pipes for the best mix of notes, and you can hear the compromise when the music is played. However, it sounds pretty good considering. The solenoids are controlled from 8 relays connected to the microcontroller. The solenoids are connected to the air valve plungers by a heavy wire link. I used a musical instrument tuning application on my Droid smartphone to tune the pipes. The application is Piano Tuner by Soundlin. Direct buttons for the solenoids are provided to control the pipes separately. I first adjusted the airflow using the rheostat to get best quality notes from all pipes. I cut the pipe length and moved the pipe cap up or down to get the proper note. Length is very sensitive, and the tune on a warm day will change on a cold, wet day. The microcontroller controls the solenoids to play the music. The microcontroller is a very common Arduino type. The program is written in an abbreviated C++ language. Google Arduino for more information on the microcontroller. The microcontroller controls 8 relays that provide power to the solenoids. Here is the wiring for the Calliope car. The program uses numbers in a dataset to control the 8 solenoids. By changing the dataset, music that stays within an 8-note scale can be played. The dataset is a series of 3 numbers per note of the music. The first number represents the note, the second number represents the duration of the note, and the third represents the duration of the pause before the next note. If you read music, it should be easy to translate any song into the numbers for the dataset.
I hope you found the videos, pictures, and narration useful and interesting. The Calliope car can add another dimension to your layout and provide you a challenging learning experience you can use on other projects.
If you wish more details or copies of the wiring diagram and program, please contact me via email.